Unit 3, Section 3.1, page 36, 37, collecting like terms, nothing new. Question 1D says this. I've got to collect like terms in each of these expressions, obviously got to simplify it. So I've got 2x minus 10x and then plus 3x. Well, let's do it this way, shall we? 2 take away 10 is minus 8, so we've got minus 8x so far. Don't forget to add the 3x later on. So I'm just showing you all the steps here. Minus 3 plus 8 is minus 5, and therefore minus 5x is done. Let's just do 1g as well. I've got 6d minus 3d, just operating grade F here, plus a d, and then minus 5d's. There you go, come out a bit better. Right, 6 take away 3 is going to be 3d's, and 3d plus d is 4d, so I'll write it down in case I forget. So 4d take away the 5d that's still sitting there. 4 take away 5 is minus 1, so you have a minus 1d, or better still, just minus d. Do the last one over here. I've got 10f's, take away 4f's, take away 3f's, and take away 2f's. Well, they're all f's, aren't they? So 10 take away 4 is 6, 6 take away 3 is 3, and 3 take away 2 is 1. I've got a single f left, and that's it. Question 2 is quite nice. They've given us some shapes here. We've got to write an expression for the perimeter of each shape. Well, you may remember that the perimeter of each shape means the distance around the edge. I've got something like that, and this is called 3y. This side is labelled 4y. This side is labelled y. Please avoid the rock climber. We don't want him to fall off in the middle of the video, do we? And this edge is called 5y. So what have we got then? We've got 5y. That's him. Plus 3y. That's him. Plus 4y. That's him. Plus y. That's him. All together 5, 6, 7, 8, 9, 10, 11, 12, 13. So the perimeter of this shape is 13y. Because we have the same term in each place, in each of the 4 sides, then we just got y's only to worry about. So it's dead easy. 5 and 3, 8, plus 4, 12, plus that 1y makes 13 y's. That's the perimeter. Let's try a more challenging one over here. First I've got to draw it. That's challenging. It's a wonky pentagon by the look of it. Something like that. Anyway, this is question 2f. This side is called 6d. This side is called 4d minus 3. Look, there's numbers now. This side is called 3d plus 1. This side is 2d. And this side right there is d plus 6. So essentially the perimeter is all these 5 sides added together. I'm going to sort of try and make it fit down here. So I've got d plus 6 plus 6d's plus 4d minus 3 plus 3d plus 1. I'm running out of space here. I hope it fits. Plus 2d. Now is that on the video? We'll see how it goes. So that's all the 6 sides. 1, 2, 3, 5 sides, sorry. So what have we got here? We've got a d plus 6d. Let's just do the d's first. That's 7d plus 4d is 11d, plus 3d is 11, 12, 13, 14d, plus 2d. I've got 16d's. Now we'll do the numbers. Just change colour. I've got 6 take away 3 is 3, and 3 plus 1 gives us 4. So I've got 16d plus 4. Let's just check it. Do this in red. So 1d plus 6d, so it's 7, 11 plus 3, 11, 14, so 16d's, that's correct. And now we'll do the numbers. We've got 6 take away 3 is 3, and 3 plus 1 is 4. 16d plus 4. So I'm quite happy with that answer. Let's turn over the page. It's getting a bit cluttered, isn't it? And back to yellow. Question 3, I'll do a couple of these. It says, write down an expression for the angles on each of these straight lines. So that's meant to be a straight line. I've got an angle there and an angle there. This angle is called 40p, and this angle here is called 30p, and this angle here is called 50p. Not 50p as in money, let's make this a bit bigger, but 50 lots of p, whatever that is, but who cares about that? Let's read it again. Write down an expression for the angles on each straight line. Well, the total of the angles, what's that going to be? I've got 40p plus 30p plus 50p all together now. 70, 120p degrees. That's the full expression. I know this comes to 180, but he's not asking us to go any further, not at this grade. The last one, it's a nice one. This I've got a 90-degree angle there shown by that sign, and I've got this and that, and this has got angle 2x, that's angle 2x, and that's angle 2x, and these could be a lot bigger obviously, but the angle stays the same. And write down an expression for the angles on each straight line. Well, I've got a 90 degree plus 2x degrees plus 2x degrees plus him as well, 2x degrees. Altogether I've got 6x plus 90, and that's in degrees. Alright, so a simple expression. Question 4, I'll just do 4b, I think. Write down an expression for the angles around the point. Well, you may recall that the angles around the point come to 360. I'm given that that's 90, doesn't look like it, but just trust me. This is 15x, this nice big angle here, and this angle is called 15x as well. That's interesting, isn't it? So what have I got? All this comes to 360, so I've got 15x plus 15x plus 90. Altogether I've got 30x plus 90, and that's all there is to it. Nothing in it really. Go up here for question 5, I think. Let's come down here. Right, question 5, I'm still simplifying, but I've got some mixed letters, so question 5, let's just do 5g, very simple. I've got 3b plus 2a, see, two different terms, minus 3b plus an a. Well, let's take it a bit at a time. I've got 3b minus 3b, haven't got any b's at all. And next little bit, I've got 2a plus an a, that comes to 3a. Very easy. Okay, carrying on with question 5 on page 37, playing at grade D. We've got a mixture of terms in these expressions. I'm going to look at 5f right now. It says this, it says 4fg's minus 3g's, and then it says plus 2, then minus 5fg's. Well, an fg is the same as an fg over there, so what have I got? Let's deal with the fg's first. 4fg's take away 5fg's, so 4 take away 5 is minus 1. So I've got a minus a single fg, minus 3g stands alone, and plus 2 stands alone. We can't merge g's and fg's, so that is the end of that one. Let's just do g, which is question 5g, that is. I've got here 3b plus 2a minus 3b and plus an a. What have I got? I've got 3b take away 3b, that's gone. I'm left with 2a plus an a. Well, that's 3a, isn't it? Very simple. Let's do the last one up here. I've got 17 minus 10m plus 5, and I've got minus 3n plus 12. Let's deal with the numbers first because they're there. I've got 17 plus 5 is 22, and 22 plus 12 is going to be 34. So I've got 34, that's the numbers done, minus 10m minus 3n. I can't merge m's and n's. I'm taking away 10m's and taking away 3n's. I can't call it minus 13mn's because it just doesn't work, it's not right. That's dead easy really. I'm told in question 5 as a standalone question I've got to show that 5x squared minus 4x squared plus x squared minus 2x squared, sorry, that equals 2x squared. Well, not very hard, is it? I've got 5x squared minus 4x squared, well, that's 1x squared alone, so just x squared, and I've got x squared plus this x squared here, and that of course equals 2x squared, and I've proved it. That's all there is to it. It's quite boring. Question 7, I've got some mixed terms here. Let's just work down here and avoid the that climber. Try not to knock the guy off again. Right, simplify the following. So this is question 7. I've got 2x squared minus 3x squared plus an x squared. Well, look at it this way. 2x squared plus 1x squared is 3x squared. 3x squared. Take away that 3x squared. Well, I've got nothing left. Answer is 0. Let me do C now. Just here, I've got 2h minus 5 plus h squared minus h. Let's just deal with the plain h's. I've got 2h, take away h. 2 take away 1 is 1. So I've got a single h left. Let's put the h squared next, plus h squared, and minus the 5 is the number 5. We can't merge it with anything. Let's write it in terms of, so that's equal to that. Let's write it in terms of the highest powers first. So it's h squared plus a single h, there it is, minus 5, and that's what that is. Alrighty then, let's get one more. Let's go over to this side of the book. I'll do the last one. I've got 5t squares plus an m square, so I know they can't be merged, minus 3m squared minus 6t squared. Let's do the t's first. I've got 5 of them minus 6 of them. That's minus a single t squared, because 5 take away 6 is minus 1. Now we do the m's. I've got m squared take away 3m squared. In other words, one of them take away 3 of them. 1 minus 3 is minus 2. And we're talking about m squares. And though that's rather ugly, starting with a negative term, it doesn't matter, it's completely correct. If I turn over, I find nothing special, so I'm going to stop. That's the first video of Chapter 3, Unit 3, Foundation Level. Thank you.